The negative power rule is going to tell us what to do when we're taking derivatives with negative exponents. More importantly, we should be able to recognize that when we have something like 1 over x cubed, that we could rewrite this as a negative exponent. And that's really when we're going to be using the negative power rule. So our rule is basically the same as the power rule. We take whatever our exponent is, so if there I had the example of negative 3, if I'm going to take the derivative, I'm going to take that power, make it negative 3x, and I'm still going to subtract by 1. But this is where you need to be careful. If we're subtracting by 1, this is negative 3 minus 1, our power is actually going down. So this would be a negative 4 here. Or we could rewrite that then as negative 3 over x to the 4th power. Okay, so here's an example of that. We want to think of this rather than 4 over x squared as 4 times x to the negative 2. Then if we're going to find our derivative, dy dx, we'll multiply by our exponent, which is going to give us negative 8. We're going to subtract our exponent by 1, which gives us negative 3. And then we're going to change that negative exponent back into a positive exponent. Now we can see how this is derived if we also solve it using the quotient rule. So if I'm using the quotient rule, my dy dx will be equal to the derivative of the top is 0 times the bottom minus the top times the derivative of the bottom. And then over the bottom squared, which will give me x to the 4th. Is going to give me negative 8x over x to the 4th, which gives me negative 8 over x cubed, which is what we got using the negative power rule. So notice, our exponent basically increased by 1 to third, and we multiply the top by that negative 2. So if I want to find the derivative of 1 over x, we can write it as y equals x to the negative x, and we'll just apply that negative power rule, which is going to end up giving us negative 1 over x squared. Now if we're asked to find the equation of the tangent line to that, we can follow the same example we did before. We first need to know the y value at x equals 1, so we come back up to our original function, we find f of 1, which gives us 1. So we know we're dealing with the point 1, 1. We also need to know the slope of this tangent line at the point x equals 1, so we can use our derivative here at the point 1, which is now negative 1 over 1 squared, which gives us negative 1. So we're going to be using a slope of negative 1 at the point 1, 1, using the point slope form. That'll give us negative 1, x minus 1, or negative x plus 1 would be plus 2. We could also look at how this would appear graphically. Notice that this tangent line, y equals negative x plus 2 that we just found, is intersecting our line at the point 1, 1. And it does have a slope of negative 1. In this next example, we want to be careful because this looks like something that would use the quotient rule. But a lot of times with the denominator, it would be a lot easier if we simplified it first. I could rewrite this as 1/2 x plus 3 over 2 x to the negative 1. dy dx would be equal to, in the first one, 1/2. The x goes away. Now this negative 1 is going to turn this into negative 3 over 2, and we'll subtract our exponent by 1. And then we could simplify that, moving the x into the denominator.